So today I'm going to be talking about a paper that was recently published with me and my colleagues called Where Do We Go From Here? Harnessing Queer Perspectives to Advance Practice in Ecology and Evolutionary Biology. And this paper arose really from lived experience and from taking classes in queer history and political science and realizing that the science wasn't really matching up with the facts of nature. And so I wanted to start with this quote by Joan Roughgarden in Evolution's Rainbow. How, I wonder, does biology account for such a huge population that doesn't match the template that science teaches as normal? When scientific theory says something's wrong with so many people, perhaps the theory is wrong, not the people. And so I really wanted to begin with this idea that science and society co-determine one another. Much like organisms build their ecosystems and environments, people do too. And this relationship is reciprocal. Not only do environments alter the way that organisms respond and their behavior within systems, but they also impact the systems themselves. And so science and society do not operate in isolation. As much as scientists believe that they are apolitical, they are political because they're influenced by ideology in the society around them. And this is the first step in really beginning to queer ecology and evolution, because the field itself has been shaped by centuries of a cis-heteronormative lens. And this relationship between science and society determines what is funded, what questions are pursued, and whose voices are included in the production and dissemination of knowledge. And so these are some of the biases that exist in ecology and evolutionary biology that we have published about, such as reductionism, the simplification of smaller topics into parts that are representative of the whole, determinism, the idea that biological traits are exclusively caused by genetic factors and are therefore hardwired and immutable, as essentialism, the idea that identity is innate and promotes rigid categories, and this disregards fluidity. And then, of course, binary thinking, our tendency as humans to classify things into two categories, ignoring nuance, complexity, and exceptions that might exist in nature. And so an example of this bias is an assumption that higher reproductive fitness is exclusively achieved through male-female pairings, which we actually know otherwise, and I'll talk a little bit more about this in a second. So here are some case studies of some of the biases that exist in ecology and evolutionary biology, one of them being the non-reporting of same-sex behavior. So field biologists frequently report and observe same-sex behavior in the field, but they dismiss the behavior, oftentimes omitting it from notes, analysis, publications, and this could be for many reasons. Either they don't want to be called queer, there is bias there because of homophobia, but this really creates a reinforcing feedback loop where it's not only underreported, but it makes the behavior seem rare. And so another one is using binary sex categories to classify individuals. And so ecologists can collect data on the gonad tissue of oysters, and researchers encounter individuals with both eggs and sperm. Binary sex assumptions can lead them to exclude or force classify individuals, biasing results and undermining our reproducibility in our studies. And so this is an example of how binary thinking limits us. And so this right here is a timeline really of ecology and evolutionary biology and some of the changes that have happened across the years. I don't know why my timeline is a little skewed, but essentially what originated some of these biases is really the classification era during Darwin and Linnaeus, the idea that we can classify organisms into subtypes, that there's a hierarchy of these subtypes, and the construction of the racialized body, which also led to the construction of the homosexual body. And looking through the literature, really, what we see is that scientific homophobia has buttressed scientific racism. A lot of these studies parallel one another. And so throughout history, we see the reporting of same-sex behavior, and oftentimes, right after, it is either erased or repressed. We can see this in the 1900s with mutual aid being published. It was proposed as politically idealistic. The documentation of same-sex behavior in the 1950s, and the Institute of Sexuality in Germany publishing hundreds of studies on same-sex behaviors. It was actually one of the first institutes to be targeted by the Nazi Party in 1933 and was burned down. And so we tend to see that when there are documentation of same-sex behavior or queer scientists leading studies, there tends to be repression that follows that as well. The Lavender Scare forced over 10,000 queer scientists to be removed from federal positions, limiting our ability to influence theory. And then also, of course, we are in this ongoing era where words like gay and trans are being banned from federal grants and limiting researchers from their ability to actually partake in some of these questions. So now is a really important time to engage in these kinds of studies and to push back. And so this was a public paper we just recently published as well, called There's No Consensus on Biological Sex, which talks about the gametic approach, which is define sex by gamete size. This is currently what we use, and we propose what Joan Roughgarden suggests, which is the multivariate approach, which defines sex by multiple traits, including chromosomes, hormones, anatomy, behavior, and gametes. And we show essentially that there is no version of defining sex, that it works across all kingdoms of life in the animal kingdom. And then this gets me really into why our guiding force of this paper was, which is we were looking at marine biology texts throughout time and realizing that they were not really, that they were against our lived experiences essentially. And so this quote best encapsulates the experience that we felt. It's by Dr. Alexis Pauline Gumbs in Undrowned: Black Feminist Lessons from Marine Mammals. And she says, "What I found in marine life guidebooks were the languages of deviances and denigration, awkward binary assignments of biological sex, and a strange criminalization of mammals that would call itself the neutral scientific language of marine guidebooks. I just wanted to know which whale was which, but I found myself confronted with the colonial, racist, sexist, heteropatriarchalizing capitalist constructs that are killing me, the net I am already caught in, so to speak." And so queering EEB is an epistemological intervention. It's not just about inclusion. In fact, we don't want to be included into a racist, heterosexist system. We want to challenge the foundation of that system. And so for scientific thought to be comprehensive and expansive, it must include perspectives from diverse lived experiences. Queering EEB will reduce bias in data interpretation, avoid circular reasoning, facilitate reproducibility, and improve the retention of queer and trans scientists. Queering EEB, again, like I said, is not about representation. It's about transforming the actual knowledge that we teach from a K through 12 level, as well as at an undergraduate and graduate level. And so to queer ecology and evolution, we have to turn our attention towards how species have a multiplicity in behaviors and reproduction and kinship and association, including same-sex kinship, multiple partners, self-fertilization, and the ability to perform multiple configurations of gender that exceed compulsory heterosexuality's mandates. And so the principles to do this are to recognize the intersection of systems of oppression, like I had mentioned before. Scientific racism and scientific homophobia buttress one another, but also approaches that are focusing on decolonizing ecology and evolution also are able to queer ecology and evolution, because these struggles are interdependent. And so that is our principle number one for queering it. Incorporating queer knowledge into scientific thought as a valid framework, our lived experiences, our understanding, challenge binary and essentialist frameworks, understand that language and hypothesis framing matters and is political. And so the language we use to describe things, the questions we ask, matter, whether or not we're asking questions from a lens of deviation or from a pathologizing lens. And then the last is that science is inherently political, so scientists must engage in policy, advocacy, and collective action, and work with people outside of their disciplines to challenge themselves. And so these are our last proponent, which is not written on here, is that accept that we don't need the answers for everything. And these are the proponents of queering ecology and evolution that we have come to. And then the actions are to consider who does and does not have access to science, so including queer and trans scientists. Action 2 is building support within the scientific community, so actually creating communities where we can research together, creating collectives. Action 3 is combating misinformation through education, so this is holding public conversations, public talks. And then Action 4 is taking collective action through societies and institutions, getting societies to release public letters, getting them to stand up against these executive orders that are being passed and the misinformation that's being passed. Action 5, craft effective messaging and inform policy. And Action 6, consider the ethical implications of our research. Should we be looking for the gay gene? Is that something that if it fell into the wrong hands, that it could be misused? right? These are the kinds of questions scientists need to begin asking, and to move away from scientific inquiry that harm communities. And that concludes my talk. These are my references, and I would like to thank the UCLA Atmospheric and Oceanic Department, UCLA Lesker Institute of Inequality and Democracy, the Critical Ecology Lab, my lab, the Tripathi Lab, and just anyone in my community who's made it possible, and the history of my community, and just thankful to be here and to be giving this talk as a scientist. So, yeah, thank you for having me.